Okay, team, we are officially into the more complicated stuff with matrices. It's going to go from where it was a moment ago, like super straightforward, into something that's a lot messier and a lot dicier. Matrix multiplication is a lot more complicated because essentially what you're doing is saying, take this complicated data structure and have it interact with this other complicated data structure. It ends up, there is a pattern, there is logic to it, but I'm going to do my best to walk you through it as slowly as possible to help make sure that you'd figure it out. So matrix multiplication is not as simple as taking each term and having it interact with only the matching term. Matrix multiplication becomes having each matrix be in charge of a certain characteristic. So the best way I can think about this is that the first term in a multiplication problem with two matrices, this is going to be responsible for rows of my finished product. You can't see that at all. And this second one is going to be responsible for columns of my finished product. The utility of this is actually something that is a little dubious until you see it applied in much more complicated ways, which is one of my hesitations in teaching matrices this way, is because using it like this and knowing what it's for is often just skipped entirely, and it's what I'm going to end up doing right now because the best application that I know often ends up turning to computer science instead. So in order to stay in the realm of pure math, I'm going to do my very best to walk you through how this works, and later we'll get into the why. So thank you for trusting me as we work that way. We said a moment ago that this is in charge of rows and this is in charge of columns, which means that if you think about your resultant matrix, and I'm going to draw it huge just so we have lots of room. This is row 1, column 1. This is row 2, column 2. This is, or row 1, column 2, excuse me. I'm a little dumb sometimes. This is row 2, column 1, and this is row 2, column 2. So this first one, the top left box of my matrix, is going to be based on row 1, which is these two terms, and column 1, which is these two terms. So what I will do is take 1 times 5, 1 times 5, and add it to 2 times 7. Bizarre. Take a moment and process. I took 1 times 5 and 2 times 7, the first row times the first column, and I'm adding them together. 1 times 5 is 5. 2 times 7 is 14, which means that the first item in my final finished matrix, I'm going to leave my work up here a little bit and do another one. 5 plus 14 is going to be 19. Then, this is row 1, column 2. So I'm using the same row, 1 and 2. And my column I'm using is 6 and 8 right here. So that's 1 times 6 plus 2 times 8. 1 times 6 is 6. 2 times 8 is 16, which means that these two things together are 22. Bottom left, this is row 2, column 1. So I'm going to use row 2 down here, and I'm back over here to column 1. I'm doing my best to move slowly, but you will need to pause and rewind, and that's okay. Matrix multiplication scares a lot of people. Row 2, column 1, so 3 times 5. I'm going to start doing these in my head. Pause and slow down if you need to. 3 times 5 is 15. And 4 times 7 is 7, 14, 21, 28. 15 plus 28 is 30, 43. 43. I think that's right. Double check it. Vote this video down if I'm wrong. And then the very last thing is based on row 2, column 2, because it's row 2, column 2. So row 2, column 2 means 3 times 6 is going to be 18, and 4 times 8 is 8, 16, 24, 32, which should get me straight to 50. And so the result of multiplying this times this is going to be 19, 22, 43, and 50. It seems freaky, and so the thing that I anchor myself in when I am getting a little disoriented by this is that this is my series of rows, and this is my series of columns. So rows comes from the first matrix, columns comes from the second matrix, and as long as I keep that in my head, then I'm going to be able to figure out what the final matrix is.